All right, welcome to your last chapter 9 video. Let's get right into it. Basically, we've learned a bunch of factoring techniques and we need to apply them to some word problems. Now, before we applied them to rectangles, today we're going to apply these factoring skills to problems about projectile motion. Projectile motion is very applicable in the real world, especially in like war situations. Like if you think of artillerymen, so like here's a cannon. Artillerymen launch stuff, right? And they need to be very accurate with what they're launching because they want to hit a target, maybe destroy a factory or try to impede the progress of some troops or something like that. And artillerymen in these days literally actually do use math. They're not just guessing, they're using math to calculate where these projectiles are going to land. What we're going to be using projectile motion for today is looking at a discus. A discus is a little disc. If you've done track and field, I think it's just shot put at our school, but a discus is another kind of throwing event. Basically, this guy's going to spin, and he's going to spin, and he's going to spin, and then he's going to launch this as far as he can. And he'll hopefully hit it way out into the field. His spinning generates all the force for throwing this thing. It's kind of like a frisbee, but it takes a lot more skill to throw. So here's the question. This is the only question of today's video, but it's a decently in-depth one. And as I talk about it, listen to some different techniques that I use to make the factoring easier, okay? So first of all, the athlete, this guy, he throws a discus, this thing, from an initial height of 6 feet. So what I mean by an initial height of 6 feet is that when he releases the discus, he's spun around, he's released it, this discus is 6 feet off the ground, okay? It has an initial upward velocity or an initial vertical velocity of 46 feet per second. So at the split second when he launches this, it's going up at 46 feet per second. And I know it's kind of going out like this, but upwards, it's going 46 feet per second, and that's really the only thing we need to consider. And there are some complicated physics at work here, but just know I just need to look at the upward velocity. I want to know when, so a time, does the discus hit the ground? So after how many seconds? It'll probably be a couple seconds, right? I'm trying to find when exactly the discus hits the ground. Now, we have this projectile motion formula. Physicists have done a lot of work with mathematicians, and they've figured out that this is always the formula to use when dealing with vertical motion, and it has to do with gravity and things like that. This is a formula that if you need to use on the test, I will give it to you. I don't need you to memorize it, but I do need you to know what the different variables mean. So this height, this is our dependent variable, meaning it's going to change depending on what time we're at. So this is our dependent variable, and it is the height, of course. So the height of the discus. The formula says, hey, let's plug in a t. This is my independent variable, and this is time. So what I mean by independent variable is that I'm going to plug in different seconds. So if I plug in like 1 second or 2 seconds and then solve the formula, it will tell me what height the discus is at that split second. Okay, so that's t. Now we have some what we call constants. The constants are v sub 0 that we see here and the s that we see at the end of the formula. These are constants. V sub 0 refers to the vertical velocity. So if you notice, we've been given that in our problem, vertical velocity. S refers to the initial height. So the initial height, and we've also been given that in the problem. Typically, you will be given things in the problem and you plug them in. Okay, so let's plug these things into our formula. First of all, we don't know h yet, we'll talk about that. We don't know t, and in fact, when tells me that I'm actually solving for t. I do know v sub 0 though. So instead of v sub 0 times t, I'm going to write the initial velocity. I know the initial velocity is 46 feet per second. Okay, good. And then instead of the plus s at the end, I'm going to write the initial height. So 6 feet. But I have two variables here still left over. Which one am I trying to solve for? Well, okay. It says when. When does this thing hit the ground? So since I'm asking when, t is definitely what I'm solving for. Solvings, I don't know what I'm writing. I'm trying to write and talk at the same time. Okay, but when does it hit the ground? Now let's think about this. It starts at an initial height of 6 feet, right? What is the height when the disk hits the ground? How far off the disk is it when it hits the ground? Well, that's 0, right? If it's right on the ground, the height is 0. So I'm trying to solve for the t that's going to give me a height of 0. And all of a sudden, now I see an equation with just one variable. It looks like a polynomial, and so we know how to solve this. And look, thankfully, since I plugged in 0 for h, kind of my first step of solving these, get the 0, is done. So let's go through the process of solving with polynomials. I got my 0, that's great. Now the second step is I need to factor. Now here's the difficulty. There are a couple difficulties. First of all, there's a negative. That's not good. I want to pull the negative out to the front because I don't like having a negative in front of my t-squares. Also, these are really complicated. There are many ways of multiplying to 16t squared when I set up my parentheses. I can have 1 and 16, I can have 4 and 4, I can have 8 and 2. Also, there are a couple ways of multiplying to 6, 1 and 6, 2 and 3. This is very, very, very complicated. So what would be a good idea is, let's see if I can divide by something. Let's see if there's a GCF that I can divide by to make the problem easier. Now I notice since all of these numbers are even, I should be able to divide by 2. And let's make that negative 2 to make this negative in front of the t squared go away. So I'm going to divide by a GCF of negative 2. And I'm not just going to factor it, I'm literally going to divide my entire equation, every single term, by negative 2. I'm allowed to do this because I'm doing the same thing to both sides of the equation. So 0 divided by negative 2, 0. Negative 16t squared divided by negative 2, 8t squared. Now I have a positive in front of the t squared, which is good. It'll be easier to solve that way. 46t divided by negative 2, negative 23t. 6 divided by negative 2, negative 3. Okay, now at this point, my solving is much, much easier. When I go to factor, yes, there's still a couple ways I can multiply to 8, 1 and 8 or 2 and 4, but check this out. There's only one way to multiply to negative 3, and that's 1 and 3. Now, since the number in the middle is negative, I'm going to choose a negative 3 and a positive 1. It might not be that way, but since the number in the middle is a big negative number, I'm thinking let's make the bigger number negative. Okay, so let's try some different things. I could try 8t and t first. Let's see, I have the first terms working out, of course. I have the last terms working out. Remember, for this type of foiling, I basically just need to check the middle two terms. This is negative 3t and 8t, so that's no good because that combines to 5t. Let's try rearranging the 8t and the t. Remember, rearranging might affect something, and I think it'll affect it in a positive way here. Let's take a look. I have negative 24t, and then my outers are plus t. Sorry, I keep switching to the next slide. Hey, that combines to negative 23t. So this is the winning factoring. I went through the factoring quickly, so if you're confused about the factoring, then go ahead and look back at some previous videos to figure out what I'm doing. At this point, I need to use the zero product property that says, hey, this guy, it can be equal to 0 by itself. This guy, it can be equal to 0 by itself. And let's solve. Here, easy, t equals 3 seconds. Here, easy, subtract the 1 to the other side, divide through by 8. T would be negative 1 over 8 seconds. Now, thinking in the context of these problems, which one of these answers actually makes sense? Well, it doesn't make sense to have negative time. We're not time travelers. We're not going back in time. I'm not Marty McFly from the 1985 classic Back to the Future. So it does not make sense to have a negative t, which means 3 seconds. This is my winning answer. The discus will hit the ground after 3 seconds. Nice. All right, so remember what we did for this problem. We had a starting equation, which I will give you on the test. I plugged in my constant values. V sub 0 was 46, S was 6, and I got an equation. I used dividing by -2 on both sides of the equation as a way to make my factoring easier. That's a really, really, really important step. Otherwise, you'll be trying to factor forever. You may never find the right answer. Afterwards, I factored, and I got rid of a solution that didn't make sense because it was negative. Thanks for watching.